Alright, so today we're going to talk a little bit more about Pangea, kind of getting into how those plates actually move, and if they do move, how do they move, and how do we classify those? So again, the lithosphere and the asthenosphere, we know the lithosphere floats on top of the asthenosphere, and that's why we have those plates movement. We've got convection currents kind of heating it up, causing it to move. So make sure you know all that. Again, the lithosphere is solid and the asthenosphere is partially molten, so it's kind of like that jello or the water. The lithosphere is like the boat that floats on top of it and moves and kind of bumps into everything else. Also, we talked about tectonic plates. We know that we live on the North American plate, and the Pacific plate is over here, and it likes to move a lot. And we know that California sits right here. And half of it is on the Pacific plate and half of it's on the North American plate, which causes it to have a lot of earthquakes and may eventually break off entirely. Alright, so the Ring of Fire is something that Finding Nemo talks about, but it is because there's a lot of movement, a lot of things going on around the boundary of the Ring of Fire. And of course, this includes the San Andreas Fault with California over here. So tectonic plates usually are made up of oceanic and continental crust. So that means that the actual landforms can move even though the oceans move too. So either one can move on top of the asthenosphere. So this is the theory of plate tectonics. The lithosphere tectonic plates float on top of the asthenosphere, we know this. And there are three types of plate boundaries. The first one is convergent. The second one is divergent, and the third one is transform. So make sure you got those three written down. Okay, so convergent boundaries, you can think of this as colliding. So this is continental and continental plates, and they, if you have two continental plates, that granite moving towards each other, then it's going to create mountains. So hopefully, cross your fingers that this works. Let's see if it'll work, please. Oh, it's not moving. Okay, whatever. All right. So if you have two continental plates moving, convergent boundaries means they come together. And they will collide. It'll create mountains. If you have a continental plate and an oceanic plate, the denser plate, which is the oceanic plate because basalt is more dense, will move down and the continental plate will fold upward. This could create a trench or a volcano. Maybe this one will work. Probably not. Okay. And then if you have two oceanic plates and they bump into each other, so they're coming towards each other, it will create an island. And a lot of times it'll be a volcanic island. Why is it not working? Oh, there we go. Woohoo! Okay, so this one right here is a continental plate, and this one is an oceanic plate. And this one is coming down because it's more dense, and it'll create that volcano or that volcanic island right there. So cool. Okay. Alrighty. So this is kind of what it looks like again. So two oceanic pieces of crust right here. So this one is subducting down. It'll create a little volcano. If this one is continent and ocean, this will come down and it'll also create a volcano or possibly a trench. And then right here, if you have two continental plates coming together, it'll create those mountains. So make sure you know those. So that's all converging. They're coming together. You can see those arrows coming towards each other. So that's what convergent is. Mount St. Helens is a really good example of this. This is the volcano that's in Washington State, and it's because of this plate coming down and subducting underneath our North American plate, and that magma comes up and it creates a little volcano right there. Alright, the Andes Mountains are also a good example of this. So this Nazca plate is coming, it's converging with the South American plate. and it creates those mountains that are right in there. If it'll go. Okay, I don't know what my computer just did. Okay, so we're back. All right, Andes Mountains, Convergent Boundary. We also have the Aleutian Islands. This is between Alaska and Russia, and those are also because of convergent boundaries. So those two plates are coming together, and they're forming all these islands up in here. All right, the Himalayas are also a very good example of convergent boundaries. We have this Indian plate right here and the Eurasian plate, and they're coming together, and they're causing those mountains to kind of come up and form even Mount Everest right in there. All right, so divergent boundaries is the next one. This is where plates separate. So it's actually the opposite of convergent boundaries. So they're going away from each other. Ocean and ocean, if you have an oceanic plate and another oceanic plate, we call this seafloor spreading, which is what we talked about last time, where we have those new rock coming towards the crack, kind of like our jelly donut, and everything moving away from each other. If you have two continental plates moving away from each other, then you're going to have a rift valley that will occur. So this is what a rift valley kind of looks like. You have basically this crack right here, and they're moving away from each other, and it's creating this huge valley in between. And this is the East African Rift, also in Ethiopia and Kenya. This is another example of seafloor spreading. So it's kind of coming up, and then it's going to spread apart away from each other. This is also happening. That's why we have the Red Sea. The Red Sea is actually getting bigger and bigger because the African plate and the Arabian plate, which is, I believe, part of the the Indian plate, are moving away from each other. So all that water is coming in between. Same thing with Iceland and that mid-Atlantic ridge that comes down in here. It's moving away from each other, so all that new rock is coming in and it's creating them to move away. All right, and the last one is a transform boundary. They slide past each other horizontally. A very good example of this is the San Andreas Fault in California, and this is one that produces earthquakes. So if we ever have an earthquake, it's because the plates are sliding next to each other. And again, this is where our San Andreas plate is, and that is actually what the fault looks like, which is really kind of cool to look at. And we'll see if this works. Possibly, maybe. Wonderful. Okay. So hopefully it'll work. No, not really. All right, whatever. So there you go. There's the San Andreas Fault. This one is moving this way, and this one is moving that way, and it creates that sliding action right in here, and it also creates earthquakes. All right, and just another look at the San Andreas Fault. And we're not going to take a look at this, so we're good to go. We're not going to look at that one. We're not going to look at that one. All right, so some questions for you. You can stop it if you want to, or if you want to continue on with questions that may be on your quiz, you can. Seafloor spreading occurs at which of the following types of tectonic plates? We know that that would be divergent because it moves away from each other. And of course, divergent is right here, like a mid-ocean ridge, and it's moving away from each other. All right, possible causes of tectonic motion is convection currents. We've talked about that already. So because of that heat coming up, it's going to cause those plates to move around a lot. Plate motion actually only moves a few centimeters per year. I believe this is also on your notes, so hopefully you didn't stop it and you were listening to the questions that may be on your test. But plates only move about a few centimeters per year, so they don't move a whole lot. But because we were kind of tracking them, we were able to tell that they only move a few centimeters per year. All right, so this is just another way to look at it with this convection currents and things like that, heating everything up. Alrighty, so stress makes things move. You don't really need to know that. It can lead to folding mountains and things like that. And it can cause uplift. You can have different types of mountains, folded, faults, and volcanic ones. Folded mountains are due to compression. You don't really need to know this, but you can look at it if you want to. Folds in the Rocky Mountains can be because of plates moving and things like that. Most of the world's folded mountains form as a result of continental. You should already know that. Folded mountains, same thing as mountains. All right, the Appalachian Mountains and the Himalayan Mountains were both formed by folding. We know this because it's convergent boundaries. It's still active while the Appalachian boundary is no longer active. So they're actually now being weathered and eroded. They're not getting any taller. You don't really need to know that, and you don't really need to know that. So you're good to go. Make sure you got your notes filled out, and you are ready to discuss it tomorrow. Have a great evening.